So this is the Texas Instruments SR-11 calculator. The SR here stands for slide rule. So this was the Texas Instruments electronic slide rule calculator. It was part of their release series in 1974. So this particular calculator is now 50 years old at the time of recording this video. I've refurbished it so that it now operates again, and I thought it would be worthwhile walking through how to use it in this video and showing a couple of examples of its scientific functions that you can use. So for this demonstration, I have quickly drawn out a very simple maths problem here in my journal here. So you can actually see, if you look carefully, that I've recorded this once before, but I decided I would talk you through how it operates rather than do it in silence as I usually would in these videos. So here, this is a regular Pythagorean triple triangle, so there'll be no surprises in the values we're looking for here. But we have 4 along this side, 3 for this side, and x for this side here. So we're trying to work out what the value for that is. And using Pythagoras' formula, we can use a squared plus b squared equals c squared. And so either of these can be a and b respectively. It doesn't really matter. And this one is our c squared that we are hunting for, the hypotenuse. So we can of course use our calculator to do that. There's a power on switch at the top here. Actually, let's just slide things around slightly so we can keep things on screen. Okay, so here we can do, for example, 4 squared, and there's indeed a button for squaring here, and you can see the calculator actually thinks about it, but it does indeed eventually give us the correct answer of 16. So let's make a little note of that here. And for the other side, we have 3, so 3 squared gives us 9, and so I can make a note of that here. And there's a reason I'm making a note of that here, because this calculator has no memory function. So I actually have to make a little note if I want to add these two together. So I have the 9 already in the calculator's working memory. So I can now plus the 16, and this, if I press equals, here gives us 25. So that's the value here for the squared value. And so of course, to get the x value here, we need to square root that, and again the calculator has a square root function, so I can press that here, and that gives us the value of 5. So our x value is 5. Now the other question I have here is, how can we get the angle for this particular corner here? So this is a right angled triangle, so this is 90, and so that means we can use our standard trigonometric functions here. And I've made the notations up here, and so the sine is the opposite divided by the hypotenuse, and we have both of those for this particular location, so we can use that particular function. The opposite here being 3, and the hypotenuse being the 5, the x value here that we calculated. Now, because we want to get the angle, we're not trying to get the length here of the side in question. We actually need to use the inverse trigonometric function. But again, if you look at this calculator, there are no trigonometric functions on it, despite the fact that it is considered a scientific calculator. Fortunately, Texas Instruments provided it with a comprehensive manual. And if we flick through the manual, we should be able to find, here we go, we have our trigonometric functions. So here we have sine, cosine, tangent, and then we go through and we have the inverse trigonometric functions as well. And so we have arc sine here, and they give us a couple of versions for this. They have a what they call like a quick or simplified version here with certain accuracy levels. But these have different formulas depending on the value that you're putting into the formula. Alternatively, they have the greater accuracy version here, which is what we're going to use, despite the fact that it doesn't give a super accuracy, but it gives us a reasonable accuracy, because this allows us to avoid doing 2 functions, so we have to actually calculate this value and plug it in to use here, as we'll see. So our 2 values in this case are the opposite of the angle, which is the 3, and the x, which is actually 5, because this is the squared value. In fact, let me just make a note here just so we don't make that mistake. So 5 squared is 25, obviously. So what we need to do is we need to do the opposite divided by the hypotenuse, 3 over 5. Again, we can clear our calculator here. We can do 3 divided by 5, and this gives us 0.6. And let's make a note of that value, because we're going to have to use it more than once. And in fact, if we look at our calculation here. The value that goes in, the A value here, is used in a few different locations, so it's a good idea to keep note of that. Because again, calculating it in line would be problematic on a calculator that doesn't have any memory. Okay, so we can follow the formula here, and I'll try and hold the document in line. Hopefully you can see what I'm doing as I'm doing it. So we're going to start here from this position, a squared, and so of course we just use the squared button. Okay, perfect. And now we need to multiply by 25 over 42, 25 over 42, and we get a value here. And this value is actually negative, so we can invert it using this negative sign here, and then we need to plus the 1, and we get a value here. And this minus 1 here just says that we're taking the reciprocal value, so we can use the value, the button here to do that, which is great. We now need to times by 189, so we times by 189, and we plus the 61, and we press equals if we don't have to. Now we need to times by a squared. Well, we could have made a note of a squared, but fortunately a squared is just times it just times a by itself, and so we can just multiply by, again, if we check our notes, 0.6, so we can multiply by 0.6 and multiply by 0.6 again, and then we can divide by 1500. Okay, finally we need to do the add 1, and eventually we need to times by our 0.6 again, which is again from our notation here, 0.6, press equals, and this gives us our value in radians, which is, just making a note here, 0.6434, and that'll do. Now, if we want this value in degrees, which we probably do, what we need to do for that is we need to multiply this value by 180 and divide it by pi, and this gives us the value of 36.87. So the value here is 36.87 degrees. And that is our value in degrees. And of course, that is actually the expected value for this angle in the triangle. Now, finally, if we did want to find the other angle here, we could, of course, use the appropriate calculation, but triangles, the angles add up to 180 degrees. And so what we can do here is we can deduct this from 180, and we can take the 90 off as well. So we can make this a negative number. We can plus 180, and then we can subtract the 90, which is the square here as well. And we find that the remaining angle is 53.13, and that would be the angle here. Okay, so I just thought I'd give you that quick walkthrough on this calculator. As I say, this is a Texas Instruments SR-11, comes with a handy book, because otherwise many of the scientific functions would be much more challenging to do unless you're already intimately familiar with the formulas. But I hope you thought this video about this calculator was interesting.